Hey, ladies and gentlemen, welcome back. We're in 8.3. Probably just got done doing your project with E, so you have a little bit of an idea of what you're looking at. You can see we got simplified the expression as your bell ringer, which is your warm-up. Let's go ahead and work through here. This is a good review of Chapter 7. Reduce 8 over 12 like you normally would. Both of these are divisible by 4. Okay, so this is going to be 2 over 3. I am now finished with my numbers, the coefficients out in front. Let's take care of business with the x's. 3/7 is larger than 1/4. Okay, 3/7 is just shy of a half up there. So a half is more than 1/4, so I can look at this as x to the 3/7 minus 1/4. Now, to do subtraction with fractions, you have to know that you need a common denominator. Common denominator between 4 and 7, well, there's no real nice ones. Just do 4 times 7, you get 28. So this will become 28. This one will become 28. And we'll say, okay, I multiplied 7 times what to get 28? I multiplied it by 4. So I'm going to multiply both of these by 4, so that's 12 over 28. As far as the 1/4 goes, I have to multiply this guy by 7, so I multiply the top by 7. So if I'm going to subtract 3/7 minus 1/4, that's actually this fraction up here, 12/28 minus 7/28. So when we finish this guy up, you're looking at 2/3 x to the 5 over 28. Okay, so there's your first bell ringer. Hopefully that's a good review of what you learned in Chapter 7. Okay, let's move on to 2. You should be smiling about this guy because this is just multiplication. And when we multiply, all we have to do here is add the exponents. Now be careful because you are adding a negative here, so you have 9 plus negative 13. So this is x to the negative 4. Or you could think of that as 1 over x to the 4. All right? So there's your quick review of Chapter 7. Hope you enjoyed it. Let's go ahead and move our screen up. Okay, so you can see you're going to be using the number e. Use the number e as the base of the exponential functions. Use the natural base e in real-life solutions or situations. Now, in your graphing calculator, and I'll punch this up for you here in a second. Okay, so I'm going to pause. Okay, so we're back here. It took a little bit of time to punch this in my graphic calculator. You can see I used parentheses, and everywhere you see an n, I put x in. Right? If you hit graph, this is kind of what you're looking at. Don't sweat the small stuff. We'll make sense of that graph here in a second. But let's fill in our table. Okay, best way to do that is go second graph. Here's our table. Oh, 0, we have an error. That's interesting. But let's start with 5. We got 2.49. How about 100? Well, that would take some time to get down to, so I'm going to change my table start to 100. That way I don't have to go all the way down there. I'm going to make my table change to 1,000. So when I open that up, when I go to my graph, it's going to start at 100. You can see it changes by 100 here. So we're looking at, looks like at 100, 2.70. Okay, at 5 or 200, we're looking at 2.71. And at 500, 2.72. 1,000, I'm going to have to shift this guy down here. Okay, we're looking at 2.72. I think we're going to probably be at the same deal here. At 5,000, so we're almost there. Again, 2.718, which will be 2.72. But you can see that that's pretty much the key number there. All right, I'm back. I got to obviously add to the thousandth place. So what I'm going to do is just add these in here. So this is 7.405. At 200, I'm at 2.711. At 500, I'm at 2.7156. So this would be 6. I guess I have to delete that actually. 2.716. Okay, I'm going to just shift this down to 1,000 after it turns off on me. So I got at 2.717. Okay. I'm going to change 5 here, but I'm only going to do that when I get my table back to normal. To do that, second window, going to take my table back to 0 and a table change of 1. So when I go back to my table, there she is. So at 5, we're looking at 2.4888. So I change that to an 8 if I'm going to follow my direction, which is a horrible 8. Okay, so there's everything to the thousands. Let's plot some of these on the graph. Okay, plot this on the graph. I got 1, 2, and I'm going to get off this graph real quick here. 2.25. At 3, I'm at 2.37, and you can see I'm going to end up here at 6 at 2.52. So and it's not going to get much higher up to 2.7. So as you do this, this basically goes from undefined and levels off. If you want to start talking about the left side of your graph, go to your negative numbers. So negative 2 up to 4. Okay, then we have negative 3 up 3.3. And then we have what? Negative 4, 3.1. And this is going to head basically to 2.9 as I head off the graph. So, that's negative 2. Okay, so this is going to look like a little bit of infinity. We start up here, and we're going to start to level out as you go across. So there are your graphs. We're more concerned with this stuff over here in quadrant 1 at this point. Okay, you can see that you're going to approach 2.718, even though this goes on forever. But we're going to get closer and closer to that. So, shifting ahead. Okay. So, to get the actual equation of what you're doing here, you're actually doing 1 plus 1 over n to the n. Okay? As you take this to infinity, as this approaches positive infinity in here, okay, this is getting closer to 0, but not quite. And you raise that to the n. This is what you're looking at for e. It's kind of like pi. It goes on forever. Okay, you had no time, a lot of time, I guess, to do this back in the day. So that's the formula you come up with when you solve for e. All right, welcome back, ladies and gents. Hope you have a TI-84 calculator ready to go, because or TI-83 in my case. That's really all this is. Okay, if I reduce this is 5, because e to the 8th over e to the 8th, these cancel out. So 60 divided by 12 is 5. That one's not bad, okay? How about b? Okay, so b, we're going to do 10e to the negative 5th, which is basically 10 over e to the 5th. Now, punch this in, and to approximate this to the nearest thousand, what we're going to do basically is do 10 divided by. Now, e is over here. I believe it is. Let's see if I can find it. Can't really read it. So 10 to the e would be second, in my case, natural log to the 5th. I hit, not 5, I hit enter. There's my decimal. So to the nearest thousandth, they said, I can do that. That is 0.067. Do you copy? Well, don't copy off of me, but you should be working along with it. Now, in C, it really just depends if you want to FOIL that or not. If you don't want to FOIL that, like me, all I'm going to do is type this literally in the calculator as 3 plus e to the first power, and then this whole thing is being squared. And if I hit enter, round that to the nearest thousand, so we're looking at 32.698769. Round it to the nearest thousand, that's what we would be looking at. Remember, ladies and gents, this is the thousands place, so 7 makes you round up. Last but not least, okay, let's punch this guy in our calculator and evaluate it. Simplify the following in terms of e, and then find the approximate. Oh, I guess I do have to FOIL, it's not a choice. So I got 3 plus e times 3 plus e. Ladies and gents, I hope when you FOIL you're getting this guy, which is then finally 9 plus 6e plus e squared. So there's the first part. There's your first part. And that one's finished. Let's vote. If you evaluate this, this is basically negative 1,000. Negative 10 to the third is negative 1,000. And then this is e to the negative 5th, or positive 15x to the third bottom. Remember, multiply your exponents, power to a power, negative 10 to the third is negative 1,000. So this is really, I can't evaluate for x, so this is pretty much where I would stop. You can't take that past that point because we don't know what x is. Once you know what x is, you could obviously round that to the nearest now. So for now, all bets are off. Okay, so let's move on down here. We're going to graph the following. We're going to identify whether it is exponential growth or exponential decay. So definitely going to want a graphing calculator for this. So let's go ahead and punch this in here. We're going to get 4 e to 0.5x. Okay. The graph gives you an idea what you're looking at. So let's just punch up this table and we'll graph it. So it doesn't look like it ever crosses 0, which is nice. Okay, so you can think of this as plus 0. Let's start at, say, negative 6. All right? And if it doesn't change a lot, I'm not really going to graph all these. 0.9, 0.19 is not very high, very barely above the x-axis. So let's see what we get at 0. I'm not going to plot all the small ones, but maybe I should put negative 2 on here and negative 3. Negative 3, we're starting to make a significant movement almost above 1. And negative 2, we're at 1.5 almost. Then we got 2.4. So you can see this is starting to take off quick. And there will be the end of the line for us. At 0, we're at 4. At 1, we're at 6.5. And at 2, we're off the charts. So if I was doing this graph from scratch, we get really close to the x-axis, but we do not cross it. And then we start taking off to infinity. Okay? So there's your first one. Let's type in 2. Looks like it's going to shift down 4 units. Hopefully you remember that from your last section in your notes on that puzzle. So we have negative 1.5 times the quantity x plus dose. Okay? And then we're going to subtract 4 on the very end. So this is going to be shifted down 4 units. So you can see right here, this is negative 4. It's getting close to that, but it won't pass it. So let's go to our graph. And that's where about it takes off. Okay, so we can start at basically, negative 4 is not going to be on your graph, so don't waste your time with it. Start here at negative 3. Know that you're going from negative infinity. So at negative 4, you're all the way up here probably. But negative 3 is the first one you can actually plot at almost a half. Then we jump down to negative 2, negative 3. That's a nice one. And so on. Negative 1, 3.7. And now we start getting really close to this negative 4 mark, but we never crossed it. So we start from like positive infinity. And then we really start to taper off. We get close to negative 4 without passing it. So this line, y equals negative 4, never passes it. Okay? That would be your horizontal asymptote right here. This horizontal asymptote is here. There's a P in there. Okay? So this is your horizontal asymptote. That's your horizontal asymptote, 0. Okay? So pause this again. Okay, you can always plug these in the graphing calculator to see if they're exponential growth or decay. But the pattern you should be picking up on is if you have a negative exponent, this is going to be decay. That's what that means. So this one will be decay. It will get smaller as you go to the right. This will be decay because of the negative exponent. This one's going to be growth because positive equals growth. So this is going to be growth. Positive again, this is growth. Negative exponents, this is decay. And this would be decay. Okay, so positive exponent means growth. Negative exponent will mean decay. And if you don't believe me, graph them. Check it out. All right, that's the end of your notes and the end of the video. Make good decisions, ladies and gentlemen.